Today we will do about covalent bonding. In the metals, non-metals chapter, we are studying the bonding of ionic bonding. That means, simply you can understand it. Metals are the one which are electropositive, have the tendency to lose electron, and non-metals are the one which have the tendency to gain electron. So one loses and one gain transfer of electron that makes ionic bond, right? Today let us discuss about the bonding between non-metals. And such type of bonding is known as covalent bonding. Covalent bond. So you can note down. Covalent bond is defined as the force of attraction between the atoms if electrons are shared. Covalent bond is the force of attraction between the atoms in a molecule if electrons are shared to get the stable configuration. Over a long time ago we are studying. Every atom need to get the nearest inert gas configuration, then only they become stable. Every atom need to get the nearest inert gas configuration. Inert gas configuration we have studied, they are the least reactive. That means they don't react at all until because they already got the stable structure. And what he says, if an atom has got the stable structure, it does not lose, it does not gain. There is chemical reaction is the one where change in the valence electrons are involved. Supposedly earlier we have studied it. One atom loses electron, another atom gains. So if one loses, it gets a stable configuration, another gains, it gets the stable configuration. It's not necessary for always it is going to be the same. Therefore, in some cases, like the reaction between non-metals, non-metals have the tendency to gain electron. And if two non-metals are coming, then what has happened? Both have the tendency to gain electron, nobody is ready to lose, then how come ionic bond formation does not take place? And therefore, the electrons are shared to get the stable configuration, and such type of force which is existed when the electrons are shared is known as covalent bond. So what is covalent bond? It is the force of attraction between the atoms if electrons are shared. For example, the simplest example is very simple case of chlorine. Chlorine has atomic number 17, electronic configuration is 2h7. So the chlorine is having 7 electrons in the outermost orbit. Then this chlorine to get the stable configuration it needs one more electron. From where does it get the one electron? Somebody has to give. So when sodium was there, it was transferred the electron. Now, if the next sodium is also chlorine is also coming, it also has got 7 electrons in orbit, valence shell. So the one will be sharing its electron with the other one, and the other chlorine atom is also sharing the same electron. Understood? So remember when the sharing is taking place, equal number of electrons are shared between the two atoms. Don't just think that one will be sharing two and another will be sharing one. It is not possible. The sharing is equal. So between this chlorine atom, one pair of electron is shared, so it can be written as this is. And this is what is known as single covalent bond. So between two atoms, if one pair of electron is shared, we call it a single covalent bond. Understood? Covalency is the force of attraction between the atoms if electrons are shared. And if one pair of electrons are shared between the two atoms, then we call it a single covalent. Understood it clearly? This one, chlorine is sharing one electron, another chlorine is also sharing another electron. So among the sharing, one pair of electrons has taken place. So therefore, it forms a covalent bond. Clear? So single covalent bond is there in chlorine. Another example is fluorine. Fluorine's atomic number is 9. So fluorine has got 7 electrons in the outermost orbit. The next fluorine is also having 7 electrons. The sharing is taking place in this level. First one is sharing, the second one is also sharing. So between fluorine, this is the sharing is taking place. So single covalent bond is formed. Clear? The force of attraction between the atoms if electrons are shared to get the stable configuration is known as covalent bond. So one pair of electrons is shared that forms a single covalent. Now let's take one more example of oxygen. Oxygen's atomic number is 8, electronic configuration is 2,6. So oxygen has got 6 electrons in the outermost orbit. The next oxygen is also having 6 electrons in the outermost orbit. The sharing is taking place in this manner. The sharing took place. So among oxygen Two pairs of electrons are shared, therefore we say double covalent bond. Among oxygen, two pairs of electrons are shared, therefore what forms is double covalent bond. So chlorine has got single covalent bond because one pair of electron is shared. Oxygen has got double covalent bond because two pairs of electrons are shared. Now, similarly, nitrogen has atomic number 7, so nitrogen has got 5 electrons in the uppermost orbit. The next nitrogen is also having 5 electrons in the uppermost orbit. So, among them, 3 pairs of electrons are shared, so we can write it as 10 triple bond. Understood? So, the covalent bond between the same atoms. So, if one pair of electrons is shared single covalent bond, two pairs are shared double covalent bond, three pairs of electrons are shared between the two atoms, then it forms triple covalent bond. This is how covalent bond formation takes place. Covalent bond is classified into two. One is polar and the second is non-polar. Now, this compound, the bond between oxygen or bonding in nitrogen or bonding in chlorine or bonding in fluorine, that means when a covalent bond is formed between atoms of the same element, and such type of covalent bond is known as non-polar. Now, what is the meaning of non-polar? Now, let's take it this way. Oxygen has got 8 protons in its nucleus. So, among these two nuclei, because you know that nucleus attract the electrons. So, among these two nuclei, there are two pairs of electrons. Understood? So, the first oxygen is 8 protons attract the shared pair of electrons. The second oxygen also attract the shared pair of electrons. So, the shared pair of electrons are attracted equally. There is no differentiation of force of attraction because both these nuclei are having the same amount of charge. The nuclear force exerted by both are the same. So this one nuclei as well as other nuclei attracts this two pairs of electrons. So there is no difference of charge. The electrons which are attracted by both the nuclei will not be shifting, remaining in the same place. Therefore, there is no difference of charge, and such type of bond is known as non-polar bond. Understood it? That is, what can we say that when the sharing of electrons between the two nuclei or two atoms are same, equal. When the sharing is equal, and such type of bond is known as non-polar covalent bond. Remember, covalency is the force of attraction between the atoms when the electrons are shared. Two pairs are shared, double covalent bond. And when a double covalent bond or a single covalent bond or a triple covalent bond is formed between atoms of the same element, there is no difference in the force of attraction exerted by both the nuclei. Therefore, the shared pair of electrons are attracted equally by both these nuclei. So there is no difference of charge, and such type of bond is known as non-polar covalent bond. Understood it? So covalent bond will be always existed between two atoms. Don't just think the number of atoms will be always be among two. Sharing can be taking place only among two. Understood it? One atom shares its electron with the other atom. And the other atom can share its electron with somebody else. But the sharing is always between two. And when the sharing is equal, and that type of covalent bond is not polar. Understood it? Now let's take the next example of polar. Now, simplest and easiest example is either we take H2O or HCl. Now, let's take the example of HCl. Hydrogen has got 1 electron, chlorine is having 7 electrons in the outermost orbit. The sharing is taking place in this method. The sharing takes place. So, we get a hydrogen single bond to the chlorine. Now, this is also covalent. Now, let's take for the study about this one. Hydrogen is having, when you talk about hydrogen's difference, it has got only one proton or nucleus is having one positive charge. And the chlorine is having 17 positive charge. Now, this one pair of electrons which is shared between hydrogen and chlorine is attracted by this one proton of hydrogen as well as 17 protons of chlorine. So, what do you think? The force of attraction exerted by the 17 proton is slightly greater. Don't you think so? It is slightly greater. So therefore, what happens? This shared pair of electrons which should have been here, since chlorine is hydrogen is not giving the electron, if hydrogen has transferred it, then it would have formed ionic bond, but that is not possible for hydrogen. Because since it has got one electron, how could it transfer? Not possible. So this one pair of electrons which is shared between hydrogen and chlorine, what takes place? The shared pair will be shifted towards chlorine. Understood it clearly? Because chlorine is exerting larger force of attraction. Due to the stronger force of the larger force of attraction exerted by this chlorine, the hydrogen from here will be slightly shifted towards chlorine. It is not transferred, but it is shifted. Transfer, if electrons are transferred, then what bond is anti-bond. But it is not transferred, it is slightly shifted. And when hydrogen electron is shifted towards the chlorine, the hydrogen gets slight positive charge and the chlorine will be getting delta minus charge. Now, why this minus and plus is formed? Understand it this way. When this is the proton and this is the electron, so the charge is neutral. When the electron is in that particular position, the atom is electrically neutral. Now, further, keep this electron from here is shifted a little far away. Is it clear? It is slightly shifted away. Then this will be developing little positive charge and this will be developing little negative charge. Do you think so? When the electrons are shifted, slightly shifted, moved away from the nucleus, little bit far away, then the nucleus will be showing little bit of positive charge. Remember the case of sodium. Sodium has what? One electron is given, transferred, and when the electron is transferred, it develops one positive charge, full positive charge. Whereas here this one, electron is slightly shifted. Electron is slightly shifted, position is slightly shifted. Therefore, this hydrogen will be developing some amount of positive charge. And when that is approaching near to the nucleus of chlorine, the chlorine is also developing slight negative charge. So in this situation, what has happened? The sharing is become unequal. And this unequal sharing is known as polar covalent bond. So whenever a covalent bond is formed between atoms of dissimilar elements, whenever a covalent bond is formed between atoms of dissimilar element, then it becomes polar. And atoms of the same element, then it is non-polar. Understood it? Non-polar means there is no difference of charge. And polar means, you understood it? Suppose like I generally take this example, if you have been given 100 rupees to be shared between two children, you can share it 50-50. That is what is equal sharing. You can take 100 rupees and keep 90 rupees with you and give 1 rupee to 10 rupees to other person. That is also sharing. But that sharing is partial. Is it clear? The majority you keep it and little bit is given. And this sharing which is partial makes it polar covalent bond. So polar and non-polar. Understood it clearly? So HCl has got polar covalent bond. So any covalent bond between atoms or dissimilar elements, you can understand it this way. Every atom is identified due to the presence of the number of protons. The different elements have a different number of protons, and number of protons are different means the force of attraction is different. And if the force of attraction is different than what has happened, it will be polar. And if the force of attraction, the nuclear charge is the same, then it makes the compound non-polar. Understood it clearly? This is about. Now, let's take further a little bit more about other one. Now, let's take this case of methane or carbon compounds. Methane is written as CH4. Now, how is bonding in CH4 takes place? You all know that carbon is having 4 valence electrons. Hydrogen needs 1 electron to complete the object. So, complete its bonding. The sharing takes place in this method. Hydrogen has shared its electron. So, hydrogen completed its orbit, having taken 2 electrons, the orbit is completed. And when hydrogen completes it, hydrogen has shared electron of carbon. Carbon need to share the same electron. Now you can see hydrogen circle has got 2 electrons and the carbon circle is having 8 electrons. Orbit is completed. So it can be shown as like this way. Carbon single bond with hydrogen, single bond with hydrogen. And this is for methane. Understood it? And this is what is the covalent bonding in carbon compound. CH4 single covalent bond is existed between them. One pair of electrons shared between the number what I told you sharing is between 2 atoms. So there is a sharing between carbon and this hydrogen and carbon and this only 2 elements that sharing. And this is how methane structure is formed. So covalent bonding is there. Okay. Nobody? Understood it clearly? So this is what it is. Now let's study about the properties of covalent bond. Remember, easiest method to remember the properties of covalent and ionic compound is when you learn it, its opposite is applicable. Now just compare. Sodium chloride, the force of attraction between sodium and chlorine is very strong. Sodium and chlorine is very strong. That means sodium ions and chloride ions is very larger force of attraction. Understood it clearly? So stronger force of attraction is existed between them, and that bond is ionic bond. Now here in this method, what has happened? There is no difference of charge. Even if the charge difference is very minute. So the force of attraction between in iron covalent compound is very weak. Remember, Na plus and Cl minus strong force, and that is why it is ionic. And CH4, in this one, what has happened? The force of attraction between the atoms and the electrons are shared is very weak. A weaker force of attraction. And weaker force of attraction make, suppose like this one, the stronger force of attraction has made ionic compound solid. And here the attraction is weak. That means covalent compounds are generally gases or liquids. So remember the properties of ionic compound, its opposite is applicable for the covalent compounds. Ionic compounds are crystalline solid. Why are they crystalline solid? Because of stronger force of attraction between the ions. And covalent compounds are generally liquids or gases. Why are they liquids or gases? Because the force of attraction between them is very weak. That makes them liquids or gases. Understood it clearly? Ionic compounds are solid, covalent compounds are liquids or gases. Similarly, ionic compounds are good electrolytes. Electrolytes are compounds which furnishes ions. Ionic compounds are good electrolytes. And what about covalent compounds? They don't have any ion. They don't have any electrically charged particles. So covalent compounds are bad electrolytes. Ionic compounds are good electrolytes. Covalent compounds are bad electrolytes. Understood it? The very large amount of energy is needed to break the force of attraction between the ions. Sodium ion and chloride ion, the force of attraction is very strong. So you need to exert larger amount of energy to break it. And whereas in covalent compound, it does not have any ions as such. The force of attraction is weak. So if we give little bit of energy, it melts. So covalent compounds are having generally low melting and boiling point, bad electrolyte. Ionic compounds are soluble in water due to ionization. Water is a polar compound in which when any ionic compound is put, it ionizes. Since covalent compound does not have any ions, they are insoluble. Exceptional cases are there. Chlorine is highly soluble in water. Ammonia is also covalent compound, highly soluble in water. Normally, oxygen is sparingly soluble. So, normally we say that these covalent compounds are less soluble in water. Understood it? These are the common properties of covalent compounds. Just you remember ionic compound, its opposite. Now remember comparison. In ionic compound, force is very strong. Ionic compound, the force is very strong, they are solid. Covalent compound force is very weak, they are liquids. Ionic compounds are soluble in water due to ionization. Covalent compounds do not have ions, therefore they are insoluble generally. Ionic compounds, stronger force of attraction will be needed very large amount of force to break the bond, therefore they have got high melting and boiling point. And covalent compound just opposite. Clear? These are the common properties. And in case is asked, draw the electron dot structure of the following molecule. So if at all it is asked first 20 elements, you should know that atomic numbers of first 20 elements. And normally it is asked from that. And you should know the electronic configuration. Say for example, ammonia. They are given the molecular formula NS3. Draw the electron hole structure of NS3 molecule. Now, NS3 is nitrogen is having 5 electrons in the outermost orbit. Hydrogen is having 1 electron. Hydrogen is having 1 electron. Hydrogen is having 1 electron. The sharing goes like this way. The sharing has taken place. Therefore, this is how NS3 is formed. And if it is asked to draw the structure, understood it clearly? So there also, how many bonds are there in ammonia or NS3? We need to say that 3 single covalent bonds. Understood? Don't say that it is a triple covalent bond. Nitrogen sharing only 1 electron with hydrogen. So nitrogen shares is 3 electron with 3 hydrogen atoms. So what is present? There are 3 single covalent bonds. Understood it clearly? Similarly, what I told you earlier, how many bonds are there in, how many covalent bonds are there in methane? So what can we say that? 4 single covalent bonds. Understood it clearly? I'll take one more example of this similar nature. Suppose like ethylene ethene is in the study carbonation bond, that is C2H4. Its structure is remain. Carbon has got 4 electrons. It is sharing this electron with hydrogen, sharing with that of hydrogen. It is a sharing over here, hydrogen is shared. So therefore the carbon will have shared electron of hydrogen. So you can understand the bonding is completed. So we can take it as a carbon, single bond with hydrogen, double bond with carbon, single bond with hydrogen. And you can calculate the number of bonds present. If asked how many bonds are there between, how many covalent bonds are there in ethylene or ethene, don't say that 4 covalent bonds. You'll have to say that there are 4 single covalent bonds between carbon and hydrogen and 1 double covalent bond between carbon and atoms. Understood clearly? So what do we say that? Don't say 1, 2, 3, 4, 5, 6, 6 covalent bonds are there. No guarantee the marks will be given for you that, but we will have to write it as this way. Four single covalent bond between carbon and hydrogen and 1 double covalent bond between carbon and carbon. Understood? Similarly, one more, that is C2H2 is to be taken. C2H2 so the sharing has done it in this manner. So HC triple bond. Now here is also asked if number of bonds are asked. So you will be having 5 bonds. Don't say that 5 covalent bonds. What do you need to say that? Two single covalent bond between carbon and hydrogen and 1 triple covalent bond between the carbon. Don't take it into these single covalent bonds. Understood clearly? It is triple covalent bond between the carbon atom and single covalent bond between the hydrogen. And this is how the bonding is taken it. Clear? If asked how many bonds are there between this one and the following compounds, you count it. If there are double covalent bond, you need to mention double covalent bond is there. And between what all? Suppose like between carbon atom there is a double covalent bond, you need to say that between carbon and carbon there is a double covalent bond. And between carbon and hydrogen, count the number of bonds. Understood? Don't simply count it and write this many covalent bonds are there. You need to mention where are the bonds present. Clear? That's all for today. And it is been asked, mark your attendance in the comments column.